All right, so what we're going to be learning today is systems. Now, you did systems in IM1 and IM2 last year. Just reviewing with linear systems, let's say you had like an example of y equals x plus 4, y equals negative 2x minus 10. And if you were to graph these, this is just a straight review. If you were to graph these, this is called a system, is because there's two or more functions on an xy coordinate plane. If you were to graph this, you would go up 4, and then you would go up 1 over 1. It would look something like this. And then if you were to graph this, you would go down 10, and then down 2 more over 1, and it's going to look something like this. And you have two lines that intersect at this point. This is called your solution. And it's an x and a y coordinate. Wherever these two lines intersect, if they do, that's your solution. And then you were taught a couple of different ways to solve, either by substitution or elimination in IM1 and IM2. Easiest way is you just substitute this in place in this, or broken down even more simplistically, set them equal to each other, because you're trying to figure out where the x plus 4 actually equals the negative 2x minus 10. And then just mathematically solving this, you know, you plug this, you move the x's over, so you move this over, so you add 2x, and then subtract 4 to cancel this out, subtract 4, and you get 3x equals negative 14 divided by 3, and you get one of your solutions would be negative 14 thirds, and then plug this negative 14 thirds probably back into here to solve for your y. This coordinate is this solution. That's a really quick process about whenever you have two linear systems, or you have a system of linear equations, and it's asking you specifically where do they intersect. Now it's not going to say in that plane of English where do they intersect. What it's going to ask you for is what is the solution? Can you find the solution to the linear systems? Okay, what we're going to be doing is we are going to be incorporating now quadratics into this equation. So I'm going to draw a couple graphs here. And I ask you, what are, and the notes that you should have in front of you, it says, what are all the possibilities for a system of two, and then I say linear. Okay, so let's think about two linear equations. You can have two graphs that look like this, that intersect somewhere, and there would be one solution. Or you can have two lines that are parallel. How many solutions would be here? There would be 0 solutions, where this would be one solution. Why are there 0 solutions? Well, these two lines, if the slopes are the same, they're parallel, they never intersect. Or you can have something called infinitely many solutions. What this means is, let's say you have one line that looks like this, and then you have another line and it's literally identical. It might be a different equation, but let's say it's, when you graph it, it rests on the same line. So there's infinite amount of solution because it overlaps, it rests on top of each other. It's intersecting itself infinitely. The next thing is quadratics. How many solutions can you have with different quadratics? All right, well, let's look. There's a couple of different things that can happen if you have a system And what a system is when you have two or more functions. So let's take two quadratics. What are all the possible ways you can have quadratics? Well, you can have quadratics look like this. How many solutions would something like this have? 0, because they don't intersect. Or you can have quadratics that look like this. This would have one solution. Or you can have quadratics that look like this. This is infinitely many because you could have the same exact quadratic graphing, lining up on top of each other. Or lastly, let's do this. There could be two solutions. So quadratics can have anywhere from 0 to 2 solutions. Depends on where they intersect. Okay, how about last one, I say a combo. What if you have a combination of a quadratic and linear equation? How many possible solutions, what's the most amount of solutions that you could have? It's also 2 solutions because you can have a quadratic and then you could have a line that goes through it. 2 solutions. Or you could have, let's say you have a quadratic and this line doesn't exist, but this green line does. This would be 1 solution because the green line hits the vertex. It's tangent at the vertex. Or you can have a quadratic and a line that never intersect. So there technically could be anywhere from 0 to 2 solutions whenever you have a quadratic in a linear system. All right, now look at the middle part of your notes. It says find a solution by setting the 2 equations equal to each other and then solving for your x. Once you find your x, plug it back in to solve for your y. That should have been actually at the very bottom of the notes because that has to do with the 2 equations that I give you. So I'm going to refer to that middle part of the notes in a second. I asked you towards the end of the notes, it says, how can 2 functions have 3 solutions? Well, you could technically have, let's say, an odd-powered function and a straight line. 1, 2, 3 points of intersection, which would give you 3 solutions. How can you have 10 solutions? Well, you can have, let's say, you have something like this. I don't know, something like this. And then you have a line that goes through it. No matter how many, however, I don't know if this is 10 or not, but you get the picture. How do you have 1 solution? If if it just intersects 1 time. And how do you have no solutions or infinite? That is when they intersect infinitely or they're the same exact graph. No solutions means there's no point of intersections. It's that simple. Now what I'm going to do is I am going to refer to the middle of my notes to answer these 2 questions. So look, first one is how many, it's going to ask you, how many solutions does this have? Negative 2x plus 3, y equals negative 2x minus 8. All right, how many solutions does this have? Well, if I were to graph this, let's look and see what this looks like on a graph. Up 3, and then my slope is down 2 over 1. Boop. This is going to be 1, 2, 3, 4, 5, 6, 7, 8. And for this one, then it's down 2 over 1. Boop. This has no solutions because they're parallel. They don't intersect. You guys probably remember that from IM1 or IM2. Okay, but let's do this. Let's say mathematically, because I'm going to show you mathematically what happens. Mathematically, how can we figure out whether something has no solutions? Well, first you set them equal to each other. We're going to say negative 2x plus 3. We're trying to figure out where this x equals negative 2x minus 8. Now watch. If I move my x's over by adding 2x, I'm left with, watch, this cancels out and this cancels out. So I'm left with just the numbers. Let me tell you, if the variables cancel out but not the numbers, there is no solution. If everything cancels out, the answer is infinitely many solutions. Those are the two differences. Visually, if it's no solutions, they're parallel or they never cross. Infinitely many means it's the exact same line. Therefore, if you set them on both sides of the equal sign, everything will cancel out. But the questions that we're going to be more concerned with today is like the second one. We're trying to figure out where x minus 2 squared minus 2 equals x plus 1. So mathematically what I'm going to do is this. I'm going to set x plus 1 equal to x minus 2 squared minus 2, and I have to solve for my x. I have to figure out what my x equals. Now it makes it a little difficult because I have a quadratic. So what you have to do is you have to solve with the quadratic. I'm going to have x plus 1 equals, I'm going to multiply this out. This is going to give me x minus 2 times x minus 2, which is x squared minus 4x plus 4, and then minus that 2. I just took this, x minus 2 times x minus 2, to get x squared minus 4x plus 4. Okay, now my next step is I have to move this over and this over, because if it's a quadratic, I have to have one side equal to 0. So I have x squared. I'm going to subtract x to get negative 4x, negative 1x is negative 5x. I'm going to subtract 1. So I have 4 minus 2 minus 1. This is going to give me 4 minus 2 is 2. Minus 1 is going to give me 1. Okay, let me make sure that I just did that real quick. Negative x, negative 4x, negative 1x, and negative 5x. Positive 4, this is going to be 2 minus 1 and 1. All right. Now, the question is, what does x equal? Well, I have to solve using the quadratic equation. So what I'm going to do is x equals negative b plus and minus the square root of b squared minus 4 times a times c. 4 times 1 times 1 is 4, all divided by 2 times your a. I'm going through this fast because this is a STEM class and you should all be able to visually see what the heck I'm doing. And it should make sense to you that I'm dividing everything and what I'm doing with the quadratic equation. This should all make sense to you guys right now. Okay, so I'm going to get rid of all of this. So I am just left with my quadratic equation to do. Okay, so now when I do this, I'm going to have x equals negative 5 is 5 plus and minus. I'm going to square root 21. 25 minus 4 is 21 and square root that. Square root of 21 is going to give me, let's just round and say 4.6. Okay, now I want to get an actual value. So I have 5 plus 4.6, which is 9.6 over 2. Let me get my calculator to get an exact answer. 9.6 divided by 2 is going to give me, I have one solution for my x of 4.8. I don't know what my y is. I'm going to figure out my other one. So 5 minus 4.6, which is 0.4, divided by 2 is going to give me 0.2. And I don't know what my y is. I'm trying to figure out my solution, not just my x. This just showed me my x solution. How do I find my y solution now? Well, what I have to do is I have to plug it back into my original equation. Either one of my original equations. I think the easiest one to use is x plus 1. Because remember my equations on the notes, the example problem you had, x minus 2 squared minus 2, and you're trying to figure out where it intersects x plus 1. If I'm going to use x plus 1 because no matter which equation you use, it's going to still give you your same two intersecting points. I'm going to use this. This is a lot easier mathematically to do. If you use the quadratic, you're still going to get the exact same answer. 4.8 plus 1 is 5.8. And 0.2 plus 1 is 1.2. This is my solution to this system. That means if I were to take this equation and y equals x minus 2 squared minus 2, they're going to intersect at these 2 points. And this is going to make a lot more sense if I just graph this to show you. Look, I'm going to graph the first one. X plus 1. I'm going to go up 1 and then up 1 over 1. All right, and then I'm going to graph my quadratic. I have a vertex of positive 2 and negative 2. Positive 2 and negative 2. And then my shape is an invisible one, so I technically go up 1 over 1 initially, up 1 over 1 initially. And then I'm going to graph it, and it's going to look, I don't know, something like this. So that means, look, if I continue this line going up more, this point of intersection is going to be, it looks like it's going to be this one, 0.2 and 1.2 right here. And then this point of intersection right here, it looks like it's going to be, because it's further over on my x, further up on my y, 4.8 and then 5.8. Those are my 2 points of intersection. You don't have to graph this. Mathematically, you have to understand how it's done. The very last thing on the notes, I say, you can technically, if you understand how to plug this in your graphing calculator, you can plug this into these 2 equations into your graphing calculator, press the trace button, and it traces on this quadratic, and it's gonna trace. You can figure out this point of intersection, and then you can figure out this point of intersection based off of the point you are on your graphing calculator, trying to figure out the solution to the system.